because you're going to hear from those. We're going to have 5 presentations from our students, each for about 10 minutes. And then we've got a short break, and then our guest speaker, Ben Sparks, is going to come and wow you for the next hour. So I really hope you enjoy it. We'll have our first group come on up now. This group was set, their project by Guillaume Marasinger, one of the academics here, actually voted Lecturer of the Year this year from the student body for Exeter University. He set them some work on functional programming, which was quite a challenging project, and in many ways they've got the toughest job because they've got to take where a lot of their time and energy was put into learning how to program and solve this problem, and now they've got to present to you something other than just showing you their program. So I'll hand over to Alex and the rest of the team.
We're the functional programming group. Our task was to write a tautology checker using functional programming. A tautology is a statement that is always true no matter what the circumstances are. In order to write a tautology checker, you have to use certain algebraic operators, known as boolean operators. There are 4 of them. They're basically equivalent to basic arithmetic kind of functions. So if we take a true input as a 1 and a false as a 0, we can add and multiply. The first operator is called the AND operator. That's equivalent to multiply. So a 1 times a 0, true times a false, will be false. Anything times 0 is 0. So the only way to get a true output is if both the inputs are also true. 1 times 1 is 1. Second is the OR function, which is an add function, which is you only need 1 to be true for the output to also be true. So 1 plus 1 is 2, but say it's 1, so it's true. And
Right, well, the third of the fundamental Boolean operators is the not operator. Basically, when you use the not operator, you're saying this is not what this is. Since yes, I'm contradiction. But since there's only 2 possible values, true and false, what this operator does in effect is to turn true into false and vice versa. There's not really much else that can be said about this, so I'm going to move on. So, in order to fully understand tautologies, we had to get to grips with the implies operator. I think that the best explanation that we've had of this so far is from Gihan when he was explaining this to us in the first place, so I'm going to just go ahead and use that. So let's take the statement that rain implies that the ground is wet. Well, if it's raining and the ground is wet, there's no way that this can be false. And similarly, if it isn't raining and the ground isn't wet, there's nothing really contradicting it. Now let's say that it isn't raining and the ground is wet, perhaps because someone spilled a bucket of water or something. It doesn't particularly matter. Since the implied statement only works in one direction, from the... This is quite... yeah, never mind. It still holds true, is my point. But if it is raining and the ground isn't dry, say because you're standing under a tree or shelter or wherever, this is the only circumstance in which this implied statement is false. Right, I'll hand over to you now, Luke.
One way you can represent these Boolean operators is through the use of a truth table. Truth tables are made up of a series of columns, one for each operation and input. They use 2 values, 1 and 0, which represent true and false. There's every possible combination of inputs and display what output will be given for each combination.
Right, so now you know a little bit about truth tables and Boolean algebra and the functions. If we take what we were actually trying to do in the project, which was make something that could check whether something was a tautology or not, depending on what you put into it. So if we take 2 variables, say A and B, and then we add the different combinations of ones and zeros that they could have, or on and off. If we take the combinations of A, and then we take the combinations of not A, which is the same but opposing, and then we put an OR operator in between them, which is just adding them up together, we can see that it gives all ones, which is a tautology because it will always be true. If we add more variables, say A, B, and C, you get the same thing if you do the same function. So if you get A and not A, and you put an OR operator in between them, it's still a tautology. And from this we can conclude that if you have a tautology which uses A, B, and C in the variables, if you add more variables onto the end of the list of your variables, so like 6 of them, it will still be a tautology as long as you do the same function. However, if you take something that has 4 variables and not use the third one, so you use A, B, and D, if that's a tautology, then if you take something with 3 variables and disguise the last one as the last one you just did, it won't be a tautology because the variables that you use will have different combinations of inputs and outputs. There's a lot of different tautologies in written literature. My favourite is probably from quite a well-known writer. So if you take 2b, you take not 2b, you put an OR operator in the middle, we just say that's a tautology. So to be or not to be, that is the question. However, the answer is yes.
So I just saw that everyone had something with truth tables. These took a while to write out by hand, so we went to Microsoft Excel for them. This was faster, it was more reliable, and it made any errors that we had nothing obvious. Now, to make the tautology checker itself, we had to do this by programming. So one programming language that we used was called Pascal. We've been using this in computing lessons. John tried to make a tautology checker in Pascal, and it worked, but it didn't use functional programming, which is a type of programming. Because that asked us to use functional programming, we decided that we couldn't use that program. Dehan suggested that we used a language called Haskell. Haskell would be better for the task, but none of us had used Haskell before, and although we tried to learn Haskell, we didn't learn enough in the time that we had, so we decided to not use Haskell either.
So we decided to use Python because it's a very basic language that we've had some experience in before. So the first program we made didn't exactly work. So we went off and talked to Gihan, and he recommended we use something called reverse Polish notation. So we incorporated this into our program, and it pretty much worked.
Yeah, but we soon found that there was a problem, and that is when we had 2 variables, such as A and B, it worked fine, but when we had a third one, such as C, it then didn't give us results that we expected. So we looked at our program,